So yeah, I'm Saurabh. I work at Razorpay. I mostly work on the libraries and design system side. I've been working on that since recently. But before that, I worked on Razorpay.com. And some of those things that I'm going to share today, you'll see like Razorpay.com examples now.
Closer, I guess.
Is it audible now? Okay, I'm not used to holding a mic, so yeah. So yeah, I work at Razorpay. I've been working on Razorpay.com, so you'll see some references here. My topic is evolution of web development. It's kind of a vague topic. I couldn't think of a better title, but evolution of web development can be talked in like different parallels. You can either just go and talk about CSS evolution or React evolution. So in context of this talk, I'm going to talk about evolution in the context of project setups that we had, the kind of project setups we had, and the server entering and client entering. You'll see some of that. So yeah, I didn't really want to start with like complete how HTML was created. So we're starting with year 2012. It's kind of like a mid-year for web now. Year 2012 is an interesting one because there were a lot of things happening in 2012, and followed by that, we were starting to build more and more complex UIs. And when I say complex UIs, we were building more and more interactive UIs. So now, obviously, the best way to start a React meetup is to show a bunch of React developers some PHP code. How many of you worked on PHP? How many of you loved PHP? I love PHP. So yeah, this code is like nostalgia or trauma based on your experience. But I won't go too much into the code. What I wanted to show was the user experience we had with this. So this is a fruit search in PHP. You just type something and it will just search for fruit and it'll return you what is the result in this. Just a static array doing starts with thing. Now, the problem with this is it's not the best experience. Like I have to type this and then press enter and it reloads the page. And we're still in a better connection, but imagine being on a very slow internet, or imagine having like a big index file or big HTML file. In that case, it will take a lot more time to reload this page, and that's just a bad user experience. But that was okay in 2012 because this is how websites looked in 2012. This is YouTube from 2012, and most of the websites looked very similar to this one. So that reloading thing was kind of accepted. Like we just accepted that is how web works, but we were moving towards more complex UIs. For example, if you compare this with the YouTube that exists today, you'll notice that in the today's YouTube, you can just hover over the video and it starts playing. You can mute it. You can just move to the next sections. It's just a lot more interactive. So whenever I say we wanted to make things more interactive, we wanted more things to be on JavaScript because PHP was just not able to do things interactive. You had to like make up your backend call and then it would return response. That it wasn't enough for making things interactive. So a lot of use cases that we were doing on PHP back then, we started moving them to JavaScript. So we'll just remove the PHP part now. This is like the basic JavaScript HTML setup. You have HTML and just importing script. Now, this wasn't perfect solution either because it got very unmaintainable very, very soon. For example, imagine having like 2 scripts or like more scripts here. And now in the index.js, I just write code like this, where I do get text and I use $. Now, where is this get text coming from? Or where is this $? Coming from? There is no modularity in the code. And also, it was very difficult to do something like managing state or creating search in this code because it's like you have to go to DOM and then just write HTML in that. It's just very difficult to build interactive experiences on this sort of code. So we started moving towards few things better. I'm skipping 2000. I'm skipping like 3 years now. This is like overview of 3 years. 2013 Webpack was released. 2013 React was also released. 2014 Babel was released, and 2015 we got a big improvement in JavaScript with ES6. The reason I'm skipping this is even the Webpack was released in 2013, it never really got popular until 2015. So in 2015, Webpack plus Babel plus React with the ES6, they kind of got popular together as a setup So Webpack and Babel were already integrated. Babel used to be a loader to Webpack, and then React, React released ES6 classes, and the classes component were getting popular. So this entire thing got popular in 2015. So let's talk about 2015. So before this, I wanted to just go through these things one by one. So first is Webpack. So just want to focus on bundlers because I think they play major role. They played major role so far, and they'll be playing major role in future as well. For the context of this talk, I'm using Webpack, but just there were a bunch of bundlers. There was Browserify first, then there was Webpack, and there's Rollup, Parcel. But for this talk, we'll just use the Webpack examples. Remember that code that I showed earlier where we just had get text and dollar and we didn't know where it was coming from? With bundlers, we kind of got that with bundlers, things became more modulated where you could import things so you know where something is coming from. Things became more and more maintainable. State management was still an issue, but regarding bundlers, so obviously there's this part where it made things modulated. There's also another helpful feature that bundlers gave was they bundled things properly, where if you write like 10 files, they won't be 10 different JavaScript files in your production. This will just be like one bundle, or maybe there'll be like a vendor bundle and then the main bundle. So let's talk about bundlers in more detail. The reason they played a major part was because a lot of these tools just kind of connected to bundlers. In this case, Webpack. This is, for example, is an example of how to connect TypeScript to Webpack, where you just define .ts and you use TS loader, and it will pick the TypeScript code. It will do its magic. It will give you JavaScript code. Same thing with Babel. It could take the new JavaScript code that browsers didn't understand or that older browsers didn't understand. It did its magic. It gave out the JavaScript code that older browsers understood. This is how a lot of other frameworks work as well, where they just have their own loaders. For example, Vue if you use Vue.js, you can just target .vue. You can use Vue loader. So it will take the Vue component. It will do transformations and it will give you JavaScript file. You can technically go and create your own language. This is a very weird name for a language, but just for this example, you can just go and create your own syntax. You can write a transformer. You can write a loader that takes your syntax, just do the things that you wanted to do and give out the JavaScript somehow. And this will work with Webpack. The point was everything was coming to this central piece where everything was able to connect to this piece. And this was very helpful. For example, I gave Vue's example. Svelte works the same way. MDX works the same way. Bundlers became this central piece that everything just connected to. Now we'll keep that bundlers information aside for now. We finally had React and we could do state management. So this is the same example that I showed with PHP. But if you notice, the experience is a lot better. I can just search interactively. So this solved our interactivity problems. So the thing that I mentioned that we were moving towards more and more interactive applications, it was kind of solved with this setup, which is great. So we just solved all problems, right? Except we didn't. There were problems that came with moving things to JavaScript. One of the things was the initial loading problem with client-side rendering. If you opened your HTML file in a React applications, you notice that it just has div root, an empty root without any code in it. You just fetch JavaScript, and or from that you just generate the HTML that you want to render, and on the client side it is added. So there's usually this waterfall in a lot of projects where they just have a bunch of JavaScript. They have to fetch a bunch of JavaScript in order to eventually render the page. And this is a performance issue because the more people work on it, more people add code into this JavaScript just goes on increasing and your initial load just gets worse and worse and worse. We solved that problem with SSR, and SSR wasn't like a new thing introduced. It just got popular eventually once we realized some of these issues. SSR was in fact there before even like React was called React. SSR, what we do with SSR is we make a fetch request. Like whenever user opens a website, it makes a request And on the server itself, you can take the React components and then you can turn them into HTML. We'll see some examples of that. And that solved the initial rendering problem because now you could add more JavaScript libraries and it wouldn't really impact the initial render as much. Most of things were moved to server. Let's write some example. Let's write some code. I usually understand things better when there's a code. This is a classic counter component. You see hello here, 0 here, and there's a button that just does the count plus. So clicking on this button should increase the counter. I'm clicking on this button, but it's not really increasing the counter. So what happened here? Here I have counter.jsx, entry client, and entry server.jsx. Some of these things are things that will be abstracted out of you if you're using Next.js. So you might not be calling these functions, some of these functions yourself, but Next.js is calling them for you. But it's really fun to understand some of these things. This is entry server.jsx. What I'm doing is React server, importing React server and calling render to string. Render to string is a function that takes the JSX, gives you the HTML. I can actually console log this and show you. This thing you see here, is it visible? Yeah. This thing you see here, if you see, it's just HTML. It doesn't really have any JavaScript. So we're taking this component and we're turning it into HTML so that we can render it. We can just return it from the server. And one of the reasons why this count plus is not working is because this doesn't have an information on where the click listeners are or how to make this counter work. That is done on entry client, and I have this thing commented out. So so far we've been calling this we call this a render, where we're just generating HTML. There is another term called hydration. Hydration is the term where like there's a React DOM hydrate root function. What it does is it just looks at the HTML that was returned from server and it kind of tries to attach event listeners on top of that. So if I just go and remove this comment, this counter starts working because now we're taking this document.query selector app. It's the same, by the way, HTML inside which we are rendered to string, and it's kind of a requirement. You can just use the same root and it has to return the same HTML, return the same JSX. So here we're just passing the same counter function again. So here we pass counter to rendered string. We are passing it same thing to hydrate root. Now there are limitations to hydrate root though. One is that hydrate root can only be called once on one React DOM tree, which means I can't go, if I have like multiple components, so it's a navigation bar and a footer and a header and other components, I can't go and say just hydrate my navigation bar and don't hydrate the rest of the page. It's like you just have to hydrate it all together at once. Let's see why that is a problem. But before that, I wanted to show you some Razorpay.com examples. Razorpay.com is kind of on the similar setup where it renders to string on server. We also cache on CDN, but and then we hydrate on the client side. So if you see this page, it's just rendered on server, and then these interactions that happen, they happen on the client side. One cool thing that I want to show was, let me. Let's disable JavaScript for this page. Now, if it was a client-side rendered app, one is that it requires JavaScript and it's in the like a lower. If the rendering is happening in like some lower JavaScript, it will just take time. But server rendered pages, in fact, work without JavaScript as well. So if you see this page, it still loads fine, but you'll see some weird things happening. For example, this testimonial doesn't work, or this navigation bar that is not working anymore because that works with JavaScript and it needs hydration. So like, again, what are the problems with hydration? Let's just see that once. Let me. Okay, so what I'm trying to do now is just show you why hydration was bad and why this is a problem. Let's just say this component, like we saw, it works without the hydration. It was working even when the JavaScript was disabled. So this technically doesn't need any JavaScript, right? But if I just go to this bundle and try to search, you'll notice that this text or all these components, they still exist in your bundle. So it's a very unnecessary bundle. It's adding very unnecessary code because if you see this website is huge and only like 2 or 3 things are like interactive. So I don't really need to ship this much code. Um, we'll see how we solve that. So yeah, this is like the same problem where if you add more JavaScript, our initial rendering is solved by SSR. So yeah, but the interactivity is still a problem. It's taking so much time to make things interactive. So by the way, what this means for user is they open razorpay.com, they try to hover over this and it will just not come, or it will be laggy, or it will just take time to load this navigation bar when everything else is loading. Right now, it's just working really fast, but it's probably cached on my laptop. But there's like some initial time where JavaScript takes to like load the bundles, run the bundles and stuff. So this is a problem that we're trying to solve with something called React Server Components. What React Server Components does is it lets you mark a certain component as a server component. It lets you mark it as a component that doesn't need client-side JavaScript anymore. We'll see what this means. This is like the ugliest looking razorpay.com I could make. It has navigation bar, which is like interactive part, like we saw in razorpay.com. And there's like some static code here. I have navbar, hero, and footer. Let's see the hero code first. This is just static code, right? It's just like rendering H1, or it doesn't need any client-side JavaScript to work. Let's see footer as well. Footer is also similar, where it doesn't need any client-side JavaScript to work. It's just very static code. Navbar is the part that is interactive. We define a certain component as something that should be in bundle is by using this directive called use client. There was a confusion I had that use client meant it renders on client. It does not. It still renders on server, but it can also do client side things is what they mean. So it ends up in your JavaScript bundle. So here I have this on mouse enter. This is like just code to make things interactive. And because this is a client component, this is working fine. Let's see what this means. Let me just open it in the other tab so we can inspect things. Remember how I said that some of these headings that are in Razorpay that are on razorpay.com that don't really need client-side bundle. Let's try to search this component in our page.jsx now. It doesn't show anything. It doesn't exist. Same with IAM footer as well. It wouldn't exist. By the way, I'm just showing the final bundle to make it more understandable, but there's also another way to see what is landing in your client-side bundle and what is not. You can go to sources, and Next.js has this app internal thing, Webpack internal, where you can go to app and see which components are client, which code of yours is actually ending up in your client-side bundle. So here you can see it's just now.tsx and client.css. So now only this part is ending up in your JavaScript bundle. Let's try making this component client. By the way, let's try adding on click here. This is server component, right? Which means it has code that can be run on server. Some of the things that we normally do on React are not the things that can be done on server. For example, this on click here. If I put hello, Where is that error? Yeah, you see this error that says that event handler cannot be passed to client compo. Like it cannot be passed to server components. It will just ask you to convert this into client components. So now if we want footer.tsx to work, we'll have to put use client here because this has a client side code now. I'll just open this and we can inspect again. Let's go to this Webpack internal app client app. You can see footer comes here now because it has become a client side component which needs JavaScript. So it will just ship that JavaScript part. So this is what React Server components are. It's experimental feature. It is part of Next.js 13 though. So if you want to like play around it, you can use Next.js. This example itself is a Next.js application. So it kind of solves our issue. For example, on razorpay.com now, only this part will be interactive. The testimonial will be a client component, which will be interactive, but rest of the things will be most of the things that just work on server and only without really needing of any client-side JavaScript. So it will just reduce the bundle size a lot. It also has other features. For example, if you can make database calls from the server components, and that can just be faster. I'm not going too much into details of that, like keeping it related to performance for now. So before actually summary, the one thing that I missed adding here was, remember this diagram where I said that bundlers are main part, like the core part where everything is just integrating to bundlers at this point. React Server Components is one of those things that integrate to bundler. It'll be a Webpack plugin or a Weave plugin eventually. There is actually a Webpack plugin already. Yeah, this is something that integrates with the bundler. And bundlers are something that allow us to do this because in this code, you can see some components have use client, some components don't have use client. So bundlers are the things that will just go through your source code that we will say that, hey, this is a client component. Let me pick this and put this into client bundle. This is a server component. Let me just put it in the server bundle. And bundlers are the things that will just make this thing work. And yeah, just to summarize like the overall talk and where we are going eventually, we started with PHP, which was a bad UX because it just keeps reloading the page. We kind of solved that with JavaScript. We moved towards writing more things on JavaScript, and that solved the problem where we were able to build more interactive applications with JavaScript. That introduced more problem on initial page, because now initial page was just taking too long to load. So to fix the initial page load, we moved to SSR, and that did fix the initial page load. But the interactivity was still not fixed. It was still taking time to make things interactive. So yeah, whenever there's more JavaScript, the main thread gets blocked. So the interactivity takes time. The thing that I explained, the interactivity is still slow. And we're kind of moving towards reducing the amount of JavaScript that we ship using the server components. So yeah, this will just something that will help us not necessarily solve, it might depend on application to application, but at least reduce the time that it takes to make something interactive, and just remove the delay of whenever you're like hovering or something and something coming up, that delay will be reduced. So yeah, that's it. Thank you so much. And you can check out GitHub or Twitter and reach out to me there. If anyone has any questions, I can take them.